Let's get radical. Radical. All right, that was a song from Olivia Newton-John. You probably remember it. I kind of butchered it to death. It's Let's Get Physical. It's basically like a workout song from like the 70s. Olivia Newton-John was from Greece. I don't know what her name was in Greece, but you can go look it up. All right, 6.1, simplifying radical expressions. All we're doing in this video is going to just simplify square roots, cube roots, higher roots, stuff like that. I want you guys to do these first 4 problems. Go ahead and hit pause, do them, see as much as you can remember, and then hit play. Okay, so this is basic, like breaking down square roots and stuff like that. So this one right here, square root of 25, that's an easy one. That's just 5. 48 is... There's 2 different ways to do it. I'm going to show you kind of both ways. I'm only going to do one way from here on out. That's because you're going to need to know this way better. So this is the first way. Some of you might actually remember this way. 16 times 3. And then we take the square root of 16, which is 4, radical 3. So this is our answer. That's a good way. But when we get to third roots, fourth roots, fifth roots, stuff like that, this isn't the best way to do it. So this is really the best way. What I want to do is I want to prime factor the number. So 2 and 24, 2 and 12, 2 and 6, 2 and 3. And then I'm just going to write them there. It's 2, 2, 2, 2, 3. And then because it's a square root, I need in pairs of 2. And then in each pair, one of the 2's pop out. The other 2's get crossed out. Same thing here. One of the 2's get popped out. The other 2 gets crossed out. So the 2 2's that came out get multiplied together to make a 4. And then the number that I did not touch is the 3. Okay, if you forget how to do this, then you can go back to my video in 2.4, simplifying square roots, and you can relearn that. So if you remember, great. If you don't, go back to 2.4, simplifying square roots, and look for the video that does it this way here. I believe it might say early college, but that's okay. All right, so that would be your video. Simplifying square roots, early college. Go back there and look at it. All right, let's move on. Number 3. Again, I want to break down the 50. And if I break it down, I get 5, 5, and 2. That's 25 times 2, right? So I take one of the 5's out, cross the other 5 out. The 5 and the 3 make the 15, and then the root 2 stays in. And then this one here, some of us might be like, well, I can just break down 56 and I get some i's. Yes, we're not going to have any i's, so no i's for this particular section. We're not going to kind of use quadratic formula and all that stuff. These are going to be pretty simple factoring type problems when we get down to it. So this one here is basically a no solution, because if I can't, or no real solution, let's use the word real better, because remember this is an I and I is not real. So this one right here has no real solution. So whenever you see a square root and a negative inside, you get no real solution. Okay, some definitions. These might be definitions or not. They might just be a quick kind of going over certain things. So an index is the same as a root. So if I have this here, this is called a square root. That's pretty self-explanatory. Square root, can't spell. And then this one here is called a cubed root, and this number is the index. So technically, if you look here, there's no number. It's an invisible 2. So that's the only root or radical, when we get to it, that you don't need a number to be written. Every other root, you need a index there. So if it's a 4th root, then that would be a 4, and you need that 4 there. So this is your 4th root. And then 5th root, 6th root, 7th root, 8th roots, whatever. But the index and the root are the same thing. You just need to know what number it represents. So this one would be a 2, and that one would be a 2. They're the same. In order to get a 3, you need a 3 there, or 4, or 5, or 6, or 172. Coefficient is just the number in front of the radical. So if I have 4 times the 3rd root of 6, this 4 is my coefficient. Okay, it's just a number in front. The radicand is the number inside the radical. The number inside the radical, so that would be your 6 in this one here. And then the radical is just basically this whole thing. So we say the third root of whatever's inside, but it's basically just the whole thing. So I can say this is technically a radical sign, but when I put it together, I have all of that other stuff there as well. All right, let's kind of go down. Let's look at the index. What is the index for this, the A there? This is a square root, so the index is a 2. What's the index of the third root of B? That's 3. And then what's the index of the nth root of C? Well, that's just n. So we have 2, 3, and then n. Those are our indexes or indices. I don't know how proper math or English term for that. I think indexes is right. I don't know. I'm not going to go Google it right now. So that's that. Let's kind of go scroll down there. So everything that you've done so far, you have been dealing with mostly square roots. Remember, square roots have the 2 there. We want to find out pairs of 2. Well, now we're going to be dealing with higher order radicals. Higher order radicals are just radicals in which the index is greater than 2. So they could be 3, 4, 5, ... up through 1,012. Okay, or higher even, we're not going to go that high, but they could be any number that's other than a 2. That's what we call higher order. The work remains the same to complete them. So let's kind of go through some of these examples here, these first 5, and then I'm going to have you guys do these next 5 and so on. So this one here, up in the top, I said we can't have a square root with a negative inside. Or technically, we can't have an even root with a negative. That is a no-no. No, 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 no. Can't do that. Okay, that is against like the math law. You'll be put in jail. But I can have the third root or the fifth root. So I can have an odd root with a negative inside. So some simple kind of tricks with this is whenever I see a negative inside with an odd root, this negative is automatically going to pop out front. It's automatically going to go there. So I can rewrite this as the negative, the third root of 8. So negative third root of 8. Now I want to take my 8 and I want to break it down. That's 4 and 2, which is now 2 and 2. Okay, so I have negative third root of 2, 2, and 2. But this third root right there, you can't really see it, but it's there, it basically tells you that you need 3 numbers in the same group. So I have 3 2's, so I'm going to put a box around them. And what happened up here with square roots? So if it was a 2 and a 2, I took 1 out, crossed it out. Well, guess what I'm going to do here? I'm going to take 1 out, cross the other 2 out. So within each group, you're only taking 1 of those numbers away in front of the root there. So this third root of negative 8 is really negative 2. Okay, because negative 2 times negative 2 times negative 2 will give me the negative 8. So that's what we're saying. So this can be rewritten technically, if we want to think about it, as this. Okay, they mean the same thing. All right, they mean the exact same thing that way. All right, let's go on to number 6 there. I want to take the 16 and I want to break it down 2 and 8, 2 and 4, and 2 and 2. So this is really the fourth root of 2, 2, 2, and 2. Well, what did we say on this problem? I need the index. I need that many in a group. Well, this is the index is 4, so I need 4 in a group. So what happens is I take 1 away, and then the other 3 get crossed off, and they're gone away. So the fourth root of 16 is just plain 2. That is just a 2. Okay? Number 7 there, 243. I'm going to do the same thing. I'm going to prime factor. All right, you guys remember this from like middle school. It's probably called prime factorization. That's the proper math term. But you guys might remember it as factor trees. That's kind of like the definition that a lot of teachers use because they want you to remember it. But that doesn't really mean we remember it. We just remember the name. So 243, I can divide it by 3, and I get 81. That's 3 and 27. That's 3 and 9, and that's 3 and 3. So fifth root of 243 can be broken down as the fifth root of what? Of 3, 3, 3, 3, and 3, 5 of them, boom. And what happens? This 5 tells me I need a group of 5. So do I have a group of 5? Yeah, I do. I take 1 out, and I cross the other 4 away. So they're gone. Boom, 3 pops out. That is your answer there. Number 8, even root with a negative. No, 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 no. Well, this is an even root with a negative inside, so this is no real solution. This cannot happen, or no real root is another way I would say it too. No real root, no real solution. That is okay. There you go. That's all you got to do for those. Number 9, we like decimals. I know we love decimals. We love decimals and fractions and every other non-positive number. I know we love negatives too. Okay, so how would we do this? Technically, what I'm going to do is I'm going to take this number here and I'm going to kind of break it down. So 8, that's what again, 2 and 4 and 2 and 2. Okay, so this is technically the third root of something, some 2, but 3 times of them. Well, think about this. 1, 2, 3, there's 3 decimal places. So remember when multiplication, when I multiply numbers, I add the amount of decimals together, and that's how I get my amount of decimals in my problem. So this is 0.2, 0.2, and 0.2. Okay, you can also do this on a calculator. I'll show you here in a little bit how we can do that in subsequent videos. Not worried about it right now. So I have 3 0.2s, so 1 pops, the other 2 get crossed. So what pops? The 0.2, nothing left inside. Boom, you are done. All right, I want you to try the next 5. Some of them are similar, some of them are a little different, but I just want you to try them and see where you're at. Okay, pause video now. These 5 here I wanted you guys to do, so let's go over them here. 32, I want to break it down. 32, I'm not going to do a lot of these prime factorizations anymore. You guys can do these. What I will do is I will put the numbers of what you should get, but I'm not going to do like 2 and 16, 2 and 8, and so on. I'm not going to do all that work. That's just kind of a lot of work that you guys can do. Okay, so this is really the 5th root of 2 times 2 times 2 times 2 times 2. So it's 5 of them. Then the 5 index tells me I need 5, so I pull 1 out, and the other 4 get crossed out. So that is 2. Boom, right there. This one here, we talk about odd root, okay, and a negative inside, so the negative automatically pops out front. So it's really negative times the third root of 3, 3, and 3. That makes 27. One of the 3's pop. The other 2 3's get crossed off. My answer is just negative 3. This one here, the 6th root of negative 1. Well, I have an even root, but a negative inside, so that cannot happen. So I have no real root. Okay. This one here, number 13, we have a fraction, but that's okay because I know we didn't go over this, but let's think about this. The third root of a fraction, and if a whole fraction is in here, I can break this down. It's the third root of the numerator divided by the third root of the denominator. That's pretty cool. That's a fraction kind of square root property there. I can do that no matter what. So the third root of 1, well, what is 1? 1 is 1 times 1 times 1. So that means one of those pop, the other 2 get crossed. What is 8? 8 is 2 times 2 times 2. One of those gets popped, the other 2 get crossed off. So what happens? My answer is just 1/2, okay? 1/2. This one here, 64. If I look up here, it's 64, and I break this down, I get 2 times 2 times 2 times 2 times 2 times 2. We got 6 of them. 6? What? I need 4. Okay, that means I have a group of 4, okay, and technically 1 is going to pop out, and we'll leave that as well kind of to the next part there. But this one here also has no real root, okay? So what do I mean by that? I didn't necessarily go over this before where it talked about real roots, but real roots are numbers that are on a number line. So easily graphable. I don't even know if graphable is a word. Easily graphable. I'm going to look at that and be like, well, I don't know if that's a word. I don't know. Again, that's another word there that you can look up if you want to know if it's right or not. So this one here is technically 2 times the 4th root of 4. But the 4th root of 4 is not on a number line. You can't graph that easily. So that's why this number is not a real root. If it just told you to simplify, then this would be your answer here. But because it actually asks you to find the real root, and I know we haven't talked about that already, but that's okay, then this would be not a real root because it's not a real number. The 4th root of 4 is an irrational number, which means irrational can't be put into a fraction or a decimal and stuff like that. That's not terminating. So this is just something that cannot be graphed easily. So that's why that would be not a real root. That was there to confuse you. I hope it did its job. Oh, yeah. I want you guys to answer these two questions real quick. What happens with a negative inside the root with an even index? What happens with a negative inside root with an odd index? I want you guys to do these two real quick. Hit pause and then hit play. What happens with a negative inside the root with an even index? This means we're not going to have a real root. So not a real root, right? I can't have a number multiplied by itself. So I can't do -2 times -2 times -2. There we go. And I can't get a negative number. It will never, ever, ever, ever give me a negative number. What happens with a negative inside the root with an odd index? The negative just, right, what happens to it? It just pops out front. Okay, it pops out front, out front. I can't spell out front. There we go. Okay, it just pops out front. So for instance, this is another example here. If I have a negative inside or out front there and I have a negative inside, this negative pops out. What does that make the whole problem? It makes it positive because the negative is already there, plus the negative popped out. So it makes it a positive and then a +2 because why? Well, that's why. Okay, so that's what happened there. All right, let's go on to the next page. Okay, it says simplify each radical expression and then use absolute value symbols when necessary. What? What absolute value? We're not talking about that. Well, we kind of are a little bit, and I'll explain why we use absolute value symbols and when to use them correctly, when not to use them, and we'll go through all that stuff as well. Okay, so what I want to do is now I want to simplify, and I want to simplify as best as I can. So some of the numbers won't work out really nice, and some of the variables will as well. So we're going to kind of find out how to do all of these stuff with variables and numbers and all that good stuff. Okay, so again, 16, I want to break down 16 using your prime factorization. But 16 is, remember, 2 times 2 times 2 times 2. Then we have x to the 8, and then I have my symbol there for my radical. Well, remember, what root is this? This is an imaginary 2. You don't need to put it there, but you can if you want to. What does this number tell you? This number tells me that I have to put that amount of numbers in each group. Within each group, 1 pops, cross it out. 1 pops, cross it out. So the numbers that pop out become a 4, right? They multiply together. 2 times 2 is 4. So now we have variables. What? So how do we do this? This is kind of weird. So what I'm going to do, this is actually pretty easy. So make sure you just follow along here and write these down if you need to. I'm not going to really write them down, but you can, if you need to, write them along your margins or something. What I'm going to do is I'm going to find out how many times this 2 goes into the exponent there. How many times does 2 go into 8? Well, 4 times. Exactly 4 times, or do I have anything left over? Well, if you think about it, that goes in exactly 4 times, so that means I have nothing left over, so this would be my answer there. Okay? Here we go here. This 16, I want to break down the -16 and so on. Well, because it's an odd root with a negative inside, what we talked about, that negative automatically pops. So really, it's 3 times the third root. When we write these 3s, please make sure we're like inside this little kind of corner here. Don't write it really up high because then it looks like an exponent, and that's not very good. So this 16, what is 16 broken down? 2, 2, 2, and 2. And then we got a to the 7, b to the 8. So I need groups of 3. Here we go, groups of 3. Within the group, what happens? 1 pops out. The other ones kind of go in the trash. We just throw them away. We don't care about them. So the 2 popped out with the 3 became a 6. Now, how many times does 3 go into 7? Twice, right? How many times does 3 go into 8? Twice. So b to the 2 as well. What do I have left? Well, I still have the third root. What did I not touch? Well, I have this like lone little 2 over here that I didn't touch, so I have to stay in. Do I have any a's that I didn't kind of use? Well, we said 3 goes into 7 twice. Do I have anything left over? Sure, I got 1 a. And 3 goes into the 8 twice. Do I have anything left over? Sure, I have 2. So this is your answer for the second one there, number 16. Okay, number 17. Here we go. Now, I want to do the same thing here. I don't have any numbers, so it doesn't really matter with numbers, but I have variables. I want to look at them the same way. How many times does 4 go into 13? Well, that's 3 times, so x to the third. How many times does 4 go into 19? Well, if I do the math there, that's 4 times, so y to the 4. Do I have anything left inside? Sure I do. So I have the fourth root of how many x's were left over after I did the 4 going into them? Well, that's just 1. How many y's do I have left over after 4 went into them? Well, that's what, 3 of them, right? And some of us, we might be like, sure, I'm done, because that's what we did on all of these. Well, here's a little bit different. Here's where the absolute value bars come in. Whenever, I guess I'll write it down. Whenever you have an even root, I can't spell it as well. Okay, whenever you have an even root and an odd exponent on a variable that pops out, use absolute value. And I'll put the bars there for absolute value. So what does that mean? That means that I have an even root here, which is 4, right? 4 is even, 2, 4, 6, 8. Those are even. And the exponent on the variable that popped out is a 3. That's odd. So I have to use absolute value bars if it tells you when necessary. Okay, if it did not tell you when necessary, then you wouldn't have to. But in this case, it does, so please use them. Okay, so I use absolute value bars around variables that have odd powers with an even root. That's the only rule that you need right there. All up in the club, right there. Okay, right there. Number 18, I want to break down 48. So let's break down 48. Let me get rid of the side stuff there. So 48 can be broken down as we got 2 out front, fourth root of 48, which is 2, 2, 2, 2, 3, and then a to the 21, b to the 4. So how many 2's do I need in a group? I need 4 of them because that's what the index says. So I take a 2 out, I cross the other 3 2's out, right? They're going in the trash. Okay, so this 2 gets popped out, becomes a 4. How many A's pop out? How many times does 4 go into 21? That's 5. And then 4 goes into 4 once. Okay, and then what's left inside? Do I have anything left inside? Yeah, I do. I have a 3 that I did not touch. It literally did not get touched. I wrote it down and did not touch it. And then how many A's do I have left over? I should have 1 A left over. So I want to rewrite this a little bit nicer because it's going to need absolute value bars. Because even root, odd powers. We have a 5 and a 1. So here's how I write it, okay? This is going to be a little bit nicer here. So 4 times the absolute value of a to the 5th times the absolute value of b, or b to the 1, it doesn't really matter, and then times the fourth root of 3a. If you don't want to put these little multiplication dots in there, that's fine. You can just do 4 absolute value, a to the 5th, close that absolute value, then you got to open another one. So it looks like you have like a double absolute value here, but this one goes to the b and this one goes to the a, and then you have the fourth root of your 3a. So all of these are acceptable. They are okay. All right, what I want you guys to do is do 19, 20, 21, and 22, those next 4 problems. Use 15, 16, 17, and 18 that we just done. Remember, absolute value bars when necessary. So number 19, 20, those are ones that could possibly have absolute value bars. You just have to see. Remember, check that rule. All right, whenever you have an even root, odd power, then you need bars, if it says you need bars. Okay, so do the next 4, hit pause, and then hit play. For number 19, I have the fourth root of what? Of 2, 2, 2, 2, and 2. It should have 5 of them. And then x to the 7, y to the 13. How many 2's do I have? I have 5, so I need 4 of them. 1 pops, cross, cross, cross. Okay, the 2 that gets popped. How many x's gets popped? 1. How many y's pop? 3. If you notice, I have even root, odd powers, so absolute value, times the fourth root of 2. 1 x is left over and 1 y is left over. That's pretty nice. That worked out lovely. Number 20, I have 4 times the fourth root of 162. Well, what's 162 broken down? Holy cow, this is a big one. 2, 3, 3, 3, 3. And then you have your A's and your B's. I need 4, so there's 4. One of the 3's pop out. Cross, 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 crisscross, Crisscross. That's an old school band back in the day, like the early 90s. Okay. So 4 times 3 is 12. Then how many A's can I pull out? I can pull out 3 of them. Even root, odd power, absolute value, because it tells you up there. Then how many B's can I pull out? I can pull out 7 B's. 777. Well, that's an odd power as well. So absolute value bars also times the 4th root of, I have 1 A left over. I'm kidding. I have 2. And then I have 1 B left over. What would happen if I pulled out an even amount of variables? Then I wouldn't need absolute value bars. Okay, because those are always going to be a positive number. When I take any number to an even root, I always get a positive. When I take an number, okay, any number, to an odd root, you don't know what you're going to get. You could get a positive or a negative. Okay, and I can't do negatives inside an even root. That's not possible. That's why I have to use absolute value bars. If it tells me, sometimes it'll say, assume all variables are positive. That just means you don't need absolute value bars. Okay, number 21. Remember, negative can be popped out front. So I get negative 3rd root of what? 81 is 3, 3, 3. 3 times 3 times 3, 27 times 3 more. D to the 10, and then E to the 2. How many 3s are going to pop? 1 3 is going to pop, cross, cross. So the negative 3 is there. How many D's? You have 3 D's. And then how many E's? No E's. 3 can't go into 2, so no E's. Pop. What's left inside? The 3rd root of what? There's a 3 here that I did not touch. I have 1 D that I did not use. And then I have 2 more E's that I did not use. So there we go, right there. Number 22. We got negative 2 times the 5th root of 96 broken down. What is that? That's 2, 2, 2, 2, and 2 times 3. I believe that's right. R to the 22. So I need 5 2's. So there's your 5. Boom, diggity. Pop, cross, 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 all that stuff. That becomes a negative 4, right? And then how many R's pop? Well, I have 4 R's, right? 5 goes into 22 4 times. And then I have your 5th root of what? What's left over? I have a 3 that I didn't touch, right there, right there. And then I have 2 R's that I did not touch as well. All right, that was a quick, hopefully, explanation of all 4 of those. You got questions, please ask in class. But let's kind of move on down there. What do you notice when a variable with an odd degree pops out of the root from an even index? Okay, what do you notice? Well, we need absolute value bars if necessary. Absolute need absolute value bars if necessary. I'm surprised I know how to spell necessary. Boom, right there. That's one of those hard little words like aluminum or cinnamon. Okay, maybe those are hard to pronounce. I don't know. If absolute value bars is necessary, you can see this is forewarning for our power assignments online. If you need to, whenever you need to type in absolute value, you're going to use the letters A, B, S, right? Just like here, absolute value with a parentheses. So if you need the absolute value of x squared, you're going to hit X, then that little up arrow, then squared, and close parentheses there. Okay, so if it's absolute value of x or x to the 3rd or whatever it is, you won't actually need it that for, but that's not a big deal. You just use absolute value ABS and then parentheses there. Next one up is a word problem. In many classes, a passing test grade is 70. Using the formula A equals 10 root R, what raw score would the student need to get a passing grade if her score is adjusted or after it's adjusted? So the A stands for the adjusted score. What is the adjusted score? The adjusted score is the 70. So 70 equals 10 times the root of R. We don't know what this R stands for. How do I solve for it? I got to divide by the 10, divide by that 10, right? So I get 7 equals the root of R. Now we have a square root of R. What's the square root of R? That's the opposite of it. Oh, squaring both sides. Like square and square root are the exact opposites. So 49 is equal to R. So this is the raw score. That's the raw score. So after, this is like before, like a curve. Okay, this is basically saying, you know, somebody, they did bad on this test, didn't you figure? And they had to curve it. And so from a 49 to a 70. That's a pretty crazy curve. If you got to curve it 21 points, maybe you need to make your class easier, or you guys need to study more. I don't know. Okay, next section. This is the last section before your practice. So we're going to kind of fly through this. This is pretty simple. You're going to be able to use your calculator for most of it. There's some things you might not be able to, but I'll show you kind of how to without it. Okay, so I want to solve an equation. I want to find the value of x such that if I square it, it gives me 100. You can pretty much be like, oh, this is just 10. Well, it's also negative 10. Okay, think about this. If I take the square root of both of them, okay, I get x is equal to plus and minus 10. Why do you get a negative? Some of you are like, what? That doesn't make any sense. Well, if I plug negative 10 in to my equation, does negative 10 squared equal 100? Yes, sirs. So that's why it's also negative 10. When you take the square root from a problem, so if I'm solving the problem by taking square roots, if I'm solving a problem, solving an equation, we'll go equation, kind of get rid of the semantics there. Solving an equation by taking roots, okay? So square root, cubed root, fourth root, whatever it is. If I solve an equation by taking roots, if the root is even, which in this case it is, it's a square root, okay? If the root is even, you get a plus and a minus of the number. Okay, so let's go to number 24 here. If I take I can't take a square root because it's to the fourth power, so I got to take the fourth root of it. The fourth root. If I take the fourth root of this, all right, then I get x is equal, because it's an even root, I get a plus and a minus of 1. Plus and a minus of 1. It's only even roots. You guys have been noticing, hopefully in this lesson, that even roots are like weird. They are really, really weird. If you use your calculator, it's only going to give you one value. You have to know all the specific kind of rarities and fluctualities. I don't even know if that's a word too. Okay, of all of these even roots. Okay, you have to know them as well. This one here, I'm taking the square root of this one. So the square root of x squared is x. The square root of 0.25, you can very easily plug that into your calculator, and that's just 0.5. Okay, so that one there is oh man, I just forgot there. It should be plus or minus 0.5. Okay, you have the plus and minus there as well. Number 26, I'm going to take the fourth root of both of these. Okay, that just gives me x equals. Well, let's break up the top. Remember I said we can split these up, so it's the fourth root of 16 over the fourth root of 81. Well, 16, the fourth root is 2, 2, 2, and 2. So I can pop a 2 out, cross everyone else out. So that's just 2 over. And 81 is 3, 3, 3, and 3. So I can take 1 out, cross, cross, cross. So that's just 2/3. Well, what do we forget? Plus and minus 2/3. So x is equal to plus and minus 2/3. All right, I want you guys to do the next, I want you guys to do the next 4, okay? And hit pause and hit play. Okay, number 27, I want to take the sixth root of this one, the sixth root of this one here. You can break down 64 as to 2, 2, 2, 2, 2, 2. That gives me 6 2s, so I pull 1 out, cross, 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 and cross. I don't even know if I said more crosses. I don't know. This is just x equals plus and minus 2. That's the only thing that popped out. Square root of 900. 900. Well, that's just plus and minus 30. Square root of 900 is 30, so plus and minus because it's an even root. Cubed root. No, I'm sorry, not cubed root. Fourth root of 0.0016. That, my dear, is, remember, it's 16 is 2, 2, 2, and 2. We did this before. We have 4 decimal places. We have 4 numbers, so each of these is going to get a decimal. So I can pull out that. So that's boom. So x equals plus and minus 0.2. 0.2. Square root. Square root. What's the square root of 25? 5. What's the square root of 81? 9. Plus and minus. Plus and minus. Booyah, Grandma. Right there. X equals plus and minus 5 over 9. All right, that concludes this full-length lesson. I know the video is a little bit long, but that's okay. You need to get this down pat, and the rest of Unit 6 will be a little easier. Okay, spend more time on this, and then that'll cause you to spend less time on everything in the future. You should do all right. If you have any questions, please ask, but you should be good to go. Remember, take notes, do work, and you will be successful.